It begins here, at a facility where one of the world's most iconic drinks begins.
Behind these doors, a legacy of precision and consistency is maintained 24 hours a day, 7 days a week. Before anyone touches a machine, strict hygiene protocols are mandatory. Contamination is the enemy of quality. The primary ingredient is water. It starts as standard municipal supply, but tap water isn't pure enough. First, it passes through massive sand filters to strip away coarse particles and sediment. Next, activated carbon towers trap chlorine and organic impurities. This step is crucial for creating a perfectly neutral taste base. Polishing filters catch the microscopic leftovers, ensuring the water is visually flawless before the final purification stage. The reverse osmosis unit forces water through semi-permeable membranes, removing dissolved solids and minerals to molecular perfection. In the quality control lab, technicians test samples every hour. The chemical composition must be exact before it can move forward.
The treated water is stored in these massive reservoirs, a blank canvas ready for the secret recipe.
While the water waits, the sweetness arrives. Tankers deliver liquid sweetener directly to the processing wing.
Powerful pumps transfer the sweetener into dedicated storage silos, keeping it at a precise temperature to prevent crystallization.
Inside the dissolving tank, treated water meets the sweetener. They merge to create what is known as simple syrup. Agitators keep the mixture moving constantly, ensuring a perfectly uniform density throughout the batch.
Even this simple syrup is filtered again. We remove any potential particulates introduced during the delivery process. Flash pasteurization comes next. Rapid heating and cooling sterilize the syrup base, guaranteeing it is biologically safe.
Then, the most critical component arrives. These sealed drums contain the proprietary concentrate, the heart of the Coca-Cola flavor.
Precision is non-negotiable here. The concentrate is weighed to the gram to ensure the taste matches the global Coca-Cola standard. The concentrate is introduced to the simple syrup. As the dark liquid hits the clear base, the transformation begins.
High-speed mixers blend the ingredients into the final syrup. This concentrated elixir is now ready for carbonation and bottling.
Before the syrup can be mixed, a sample is sent to the lab. Technicians rigorously check the color and viscosity.
Once approved, the concentrated syrup is pumped into holding tanks. Here, it awaits the next crucial stage.
Meanwhile, the packaging process begins. These small plastic tubes, called preforms, are the embryos of
An unscrambler sorts the bulk load, standing each preform upright and aligning them into a rapid, single-file procession. To transform hard plastic into a flexible bottle, heat is essential. The preforms enter a long oven tunnel. Inside, banks of infrared lamps bake the plastic to over 200 degrees Fahrenheit. The rotation ensures every side is heated evenly.
Now soft and malleable, the preforms are transferred at high speed to the blow molding wheel.
Each hot preform is dropped into a specific mold cavity. This mold carries the negative impression of the distinct Coca-Cola contour shape.
In a fraction of a second, the mold clamps shut, sealing the preform inside. A stretch rod instantly shoots down the center, elongating the tube to the full length of the mold.
Simultaneously, high-pressure air is blasted in, inflating the plastic like a balloon against the cold metal walls to take on the famous curves.
Contact with the chilled mold instantly cools the plastic, hardening it into its permanent, iconic shape. The molds fly open, revealing the transformation. What was once a test tube is now the unmistakable Coca-Cola bottle. Ejected from the wheel, the bottles are stable and ready for transport.
To prevent damage, they are transported by their neck rings on an air conveyor, gliding on a cushion of air to the filling station. In another part of the plant, aluminum cans begin their life as a massive, continuous coil of metal sheeting.
The uncoiler feeds the sheet into the line, flattening it out to prepare for the stamping process.
A thin layer of lubricant is applied. This prevents the metal from tearing under the immense pressure of the press.
The cupping press punches through the sheet, stamping out thousands of shallow discs every minute. These initial cups are shallow and thick. They will eventually be stretched into the tall, thin cans we recognize. The thick aluminum cups are fed into the body maker, the heart of the can manufacturing process.
Inside, a ram drives the cup through carbide rings, stretching the metal walls to be thinner than a human hair in a process called drawing and ironing.
The stretching process leaves an uneven edge, so a trimmer spins the can and slices the top to a precise, uniform height.
Covered in coolants and lubricants from the forming process, the cans must be thoroughly cleaned before they can be painted.
They pass through multiple stages of washing, rinsing, and chemical treatment to ensure the aluminum is perfectly clean.
Once clean, the cans travel through an oven to dry completely, preparing the surface for the decorative printing that follows. Before the beverage is added, a spray nozzle coats the inside of the can with a water-based lacquer to prevent the liquid from reacting with the metal.
This internal coating is instantly cured and hardened as the cans pass under high-intensity UV lights.
Now for the exterior. The cans reach the printer where the signature Coca-Cola red base color is applied at speeds of over 1,000 cans per minute.
Precision rollers add the white script branding and nutritional information in perfect registration with the base coat.
A final layer of varnish is applied over the ink to protect the design and give the can a glossy, abrasion-resistant finish.
The wet ink and varnish are baked onto the metal as the cans wind their way through a massive curing oven. To accommodate a smaller lid and save metal, the top of the can is narrowed in a process called necking. A flanging tool then rolls the top edge outwards, creating a lip that will eventually be seamed to the lid.
Every single can passes through a light tester. Sensors detect even microscopic pinholes, and defective cans are instantly blasted off the line. The finished cans gather on accumulation tables, creating a buffer that ensures the filling line keeps running even if the manufacturing side pauses. Before filling, the cans enter a twist rinser that flips them upside down for a final cleaning. Jets of ionized air or water blast the interior to remove any dust or debris that might have settled during transport. Gravity drains any remaining water as the cans are twisted back upright, perfectly clean and ready for the beverage.
In a separate area, the beverage syrup is precisely blended with treated water to create the final product, ready to meet the cans. Precision is key. Digital flow meters monitor the streams, ensuring an exact 5-to-1 ratio of water to syrup.
Before carbonation, the mixture passes through a heat exchanger, cooling it to near freezing to maximize gas absorption. The liquid enters the pressurized carbonator tank, a vessel built to withstand significant internal force.
Here, carbon dioxide is injected directly into the stream, transforming the flat mixture into a sparkling beverage.
Inside, controlled turbulence ensures the gas dissolves completely, giving the drink its signature fizz.
Now fully carbonated, the beverage travels through an overhead pipe network to the heart of the bottling line. This is the rotary filler, a mechanical giant capable of processing hundreds of bottles every single minute.
The in-feed star wheel acts as a traffic controller, spacing each bottle perfectly for entry into the main turret. As they enter the filler, a cam mechanism lifts each bottle, raising it to meet the filling valve above. The nozzle descends to form an airtight seal. This is critical to prevent the carbonation from escaping. Before liquid enters, the bottle is pressurized with gas to match the tank's internal environment.
Gravity takes over. The liquid flows down the sides in a process called isobaric filling, which prevents foaming. A snift valve slowly releases the pressure, ensuring the beverage doesn't boil over when the seal is broken.
The filled bottle lowers away from the valve, ready for the next stage of the assembly line.
A transfer star wheel immediately grabs the open containers, handing them off to the capper before any fizz is lost. Above the line, a bulk hopper sorts thousands of caps, orienting them correctly and feeding them into a chute.
As the bottle passes beneath, it snags a cap from the dispenser, positioning it perfectly for sealing. A spinning head descends, applying the exact amount of torque needed to seal the freshness inside.
For canned beverages, the process is similar, but uses a lid feeder to dispense aluminum ends onto the filled cans.
The can is lifted into a seaming chuck, where the lid and body are about to be mechanically fused forever. The first operation roller engages the flange, curling it underneath the body hook to start the seal.
A second roller then flattens the seam, compressing the lining compound to ensure an airtight, hermetic seal.
To guarantee consistency, a gamma or X-ray detector scans every single bottle, checking that fill levels are exact.
Any container falling short of the standard is instantly identified and kicked off the line by an automatic ejector.
Cold beverages would cause condensation on the outside, ruining the labels. These warmers bring the temperature up to prevent sweating. High-velocity air blowers, known as air knives, shear away any remaining moisture, leaving the surface perfectly dry for labeling.
The bottling line's speed demands a high-tech rotary labeler, capable of applying branding with pinpoint accuracy.
Labels are fed from a continuous roll, maintained at constant tension, before being sliced to the exact length.
A vacuum drum holds the label, while a roller applies a thin, vertical strip of hot melt glue to the leading edge. The label is transferred to the spinning bottle, wrapping around it in a fraction of a second. Stationary brushes or pads wipe the label down as the bottle passes, smoothing out any air bubbles for a flawless finish. Before leaving the area, a laser coater etches the batch number and expiry date directly onto the material. A final vision system snaps a photo of every unit, verifying that the label is straight and the code is legible. Now, the single file line is divided into multiple lanes, organizing the bottles for the packaging stage. Simultaneously, flat cardboard blanks are erected into trays, ready to receive the product. A drop packer groups the bottles into the desired format, typically a 4x6 grid.
The grid of bottles is released, dropping gently into the waiting cardboard tray below.
A sheet of shrink film is cut and draped loosely over the entire pack.
The loose packs travel into a heat tunnel, where hot air circulates around them.
As they emerge, the film shrinks tight, locking the bottles to the tray for a secure, shipping-ready package.
To ensure stability during transport, the shrink-wrapped cases pass through a cooling tunnel where high-speed fans instantly harden the heated plastic shell. Once secured, the finished cases travel down the line to the palletizing area, where the final stage of assembly begins. Heavy-duty robotic arms take over the heavy lifting, capable of grabbing an entire layer of product with precise compression grippers.
The arm stacks the layer onto a wooden pallet, repeating the process until a full load is built.
As each layer is added, the pallet lift adjusts automatically, ensuring the robot never has to overextend.
Weighing over a ton, the fully loaded pallet is conveyed to the stretch wrapper for final securing. A rotary arm spins a web of stretch film around the stack, locking the cases together to prevent shifting during transit. With the load secure, forklifts move in to transport the pallets from the production floor to the logistics center. In modern facilities, automated guided vehicles often assist, navigating the warehouse floor with laser precision.
The pallets are stored in massive high-bay racking systems, holding millions of liters of product ready for distribution.
When orders come in, the stock is retrieved and brought to the loading docks for immediate shipment.
Trucks are loaded systematically to maximize space and ensure weight distribution for the journey ahead. Once full, the doors are sealed, marking the end of the manufacturing journey and the start of the delivery. From raw ingredients to a finished, bottled refreshment, the product is now on its way to stores and vending machines near you.